we are going to graph the trigonometric function y equals -3/2 cos 2x. Now what we're going to do is we're going to use a table of values for this. My original x values for original y equals cos x are 0 degrees, 90 degrees, 180, 270, and 360. Now if you're dealing with radians, that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. But if you have no idea what I'm talking about with those, don't worry about it. And then the actual values for the cosine of each of these angles, the cosine of 0 is 1, the cosine of 90 is 0, the cosine of 180 is -1, and 0 and +1 respectively. So that's just regular y equals cos x. But we are going to apply transformations to this. The first one I want to deal with is, let's deal with this 2 first. This 2 as a coefficient on x before you take the cosine is a horizontal compression by a factor of 1/2. It means we're going to cut these x's, or these x's, in half. Now the reason that's happening is that these x's only have to be half as large as they originally were for them to give the same number once it's doubled. Like cos of 360 is 1, right? But if x is 180 in this formula, 2 times 180 is 360, and cos of 360 is what gives you that 1. So the x's in this case are halved from what they were. 360 becomes 180, half of this is 135, 90, 45. Half of 0 is 0, but I'll still write it there. And I'll cut the numbers of radians in half as well. Just write those here. That's 3 pi over 4. These are awkward numbers, but we can deal with it. We have pi over 4, and half of 0 is 0. Now that's the horizontal compression by a factor of 1/2. Now, we also have a vertical stretch by a factor of, well, 1.5 or 3/2. So it's going to be 1.5 times taller than it was. We can do that by multiplying each of these coses by 3/2. I'll keep the fractions, but if your teacher lets you write 1.5, hey, go for it. This is -3/2 here. That's 0, and that's +3/2. That's the stretch vertically by a factor of 3/2. We also have a vertical reflection on the x-axis. That has the effect of flipping the signs on all of these numbers. So +3/2 becomes -3/2. -0 is 0, so that one doesn't change. -3/2 becomes +3/2. You can see everything that was once positive on the y-axis is now negative, and everything negative is now positive, and +3/2 becomes -3/2. Now it's time to graph. I'm ready. So I'm going to draw my y-axis here. I'm going to put -1 here. I'm going to put -2 here. This will be 0. This is 1, and this is 2. Here's my x-axis. Now I only have to get up to 180 degrees here. 1, 2, 3, 4. That'll fit if I put it there. Halfway is 90. Halfway to that is 45. Halfway between these is 135. Hope you liked what I did there. And I'll put the radian ones in here for you too. That's pi over 4. That's pi over 2. That's 3 pi over 4 and pi. Great. But now I'm going to put down the points, right? I've got a final point at 0, -1.5. 0, -1.5. I've got a point at 45 degrees, 0. That's the point that was originally at 90, 0. I've now got one at 90, 1.5. And now, oh yeah, this does look like cos. Cos usually starts at its maximum, comes down and goes back up. This one, because it's flipped, starts at its minimum and goes up and comes back down. You can use symmetry from here. I know that I'm going to have a point there on the other side of that maximum. But look, 135, 0. And similarly, I have a point at 180, -1.5, which is about here. try to connect these in a curvy way so that it doesn't look like straight lines. That'll make your teacher happy. And there you go. There's the graph. The point is, it's 1.5 times taller than it used to be. It's half as wide, so one cycle or period is only 180 degrees, or pi radians, and it's been flipped. So it starts at its minimum, whereas regular cosine usually starts at its maximum. Hey, thanks for being with me, and best of luck.